All right, our goal here is to discuss limits, specifically L'Hopital's rule. Not every one of these limits will require this rule because part of this rule is knowing when and when not to use it. So the first thing you try on any limit is just to sub in and see what happens. So on this number 1, we sub in x equals 0, and we're left with the square root of 5. Now, that seems like it might be too easy, but that's the point. You sub in, and if no problems arise, like an indeterminate form, then that's your answer. So our limit on number 1 is the square root of 5. So let's try again with number 2. We try to sub in directly, and we get the natural log of infinity over 2 times infinity. And now, the natural log of infinity is infinity. Natural log grows very, very slowly. It looks like this, but it is always rising as we move to the right, so eventually the natural log of infinity, it never stops growing, it's infinity. The bottom is 2 times infinity, so long story short, we have infinity over infinity. This is the perfect time to use L'Hopital's rule. Infinity over infinity is not 1, it is a case where you have to work further and do some sort of simplifying and sub in again. So this is what this rule does for us. So let's take the derivative of the top. The derivative of natural log of x is 1 over x, and the derivative of the bottom is 2. And so I can already tell I'm not going to get infinity or 0 on the bottom this time because the bottom is now just 2. So when I sub in, after taking those derivatives, I'm going to still take my infinity and plug it in. And 1 over infinity on top. Any whole number, any real number over infinity equals 0. And the bottom is 2, so our final answer is 0. All right, so there's a case where L'Hopital's rule was necessary. Let's do the next one. If I sub in on number 3, natural log of x squared, and I plug in a 1, I get natural log of 1. And on the bottom, I get 1 squared minus 1. Natural log of 1 is 0, because remember that graph I just drew a minute ago, this point right here is 1, 0. And obviously on the bottom we have 0. So again, indeterminate. 0 over 0 is not equal to 1. It means do something else. Simplify in some way. So hopefully L'Hopital's rule will help us simplify. So let's take the derivative of the top and bottom. The derivative of natural log of x squared is the derivative of x squared over x squared, which will simplify to just 2 over x. And the denominator is the derivative of x squared minus 1, which is 2x. So now if I substitute in, I have on top 2 over 1. I'm taking the 1 and substituting it in for x in my newly differentiated numerator and denominator. And if I plug in 1 on top, I get 2 over 1. And if I plug in 1 on the bottom, I get 2 times 1. And both of those things equal 2, so 2 over 2 equals 1. Final answer is 1 on number 3. Okay, and moving on to number 4, plug in 16, straightforward plug in. I get the square root of 16 is 4 minus 4 is 0, and then 0 on the bottom, 16 minus 16. Again, not equal to 1. 0 over 0 is not 1. 0 over 0 means do something else. So the thing I can do, in earlier chapters we might have rationalized and multiplied the top and bottom by the conjugate of the top, but L'Hopital's rule might make that process simpler. The derivative of the square root of x minus 4. The square root of x is x to the 1/2. The derivative of that is 1/2 x to the negative 1/2, or 1 over 2 times the square root of x. So that's our new numerator. The derivative of the bottom is 1, because the bottom is just an x and a constant. Now if I sub in, this over 1 is irrelevant, because anything over 1 is itself. And I sub in directly and get 1 over 2 times the square root of 16. And 2 times the square root of 16 is 2 times 4. And that leaves me with 1/8. All right, moving on. A little more complicated looking ones down here. Same strategy. We're going to sub in straightforward. If I sub in 0 on number 5, I get 2 times e to the 0 minus e to the 0. The bottom is 0. So remember, anything to the 0 is 1. So this set of parentheses on top is 1 minus 1. I get 0 over 0. So I need to take derivatives. All right, that's usually the best strategy for a 0 over 0 situation. The derivative of the top is going to be, so this, let me think of this as 2e to the x minus 2e to the negative x. The derivative of 2e to the x is 2e to the x. The derivative of 2e to the negative x is negative 2e to the negative x because of the chain rule, but that subtraction sign and the new negative are going to become a positive. The derivative of the bottom is 1. All right, so let me just make sure. This is what I started with. So I have negative 2. The derivative of e to the x is negative e to the negative x. Because of the chain rule, that's where that negative comes from. So those two negatives went together to make a positive. Okay, so there are my differentiated numerator and denominator. I need to sub in a 0 now. When I sub in 0 now, I get 2e to the 0 plus 2e to the 0. And both of those e to the 0s are 1s, so I get 2 plus 2 equals 4. Okay, so number 6, plugging in directly. When you plug in infinity, and we have a rational type situation, this is a case where L'Hopital's would work, but we could have solved this one without L'Hopital's before, because when you're looking for limits at infinity, that's basically horizontal asymptotes. My top is linear, meaning it's to the first power. My bottom is squared, so it's obviously bigger than 1. So if the bottom's squared and the top is linear, this thing is going to 0. Now let's say you didn't catch that, and you thought, well, I'm in L'Hopital's mood, or L'Hopital mode. So you get, if you sub in directly, you do get infinity over infinity. The derivative of the top, let me consider this negative to be part of the top. The derivative of the top is negative 9, and the derivative of the bottom is 2x. Now when you plug in this infinity, you get negative 9 over 2 times negative infinity, and that makes 0 because the bottom is growing without bound and the top is not. So whether or not you need L'Hopital's rule, it will still work for you. Okay, next one. We always plug in directly. Cosine of negative pi over 3, and this is not an indeterminate form, 0 over 0 or infinity over infinity. This is just a plain sub-in. This is basically, do you remember your unit circle? Negative pi over 3 is down here. The cosine of this angle is the x value, which is right here, and it's positive 1/2. Okay, so always try to plug in first. Number 8, plug in infinity. I get 2 infinity squared, which is infinity. And on the bottom, e to the infinity, also infinity. Perfect example, L'Hopital's. All right, so take the derivative of the top, 4x. Take the derivative of the bottom, it stays e to the x. Now when I sub in again here, I'm going to get infinity over infinity again, because 4 times infinity is infinity. E to the infinity is infinity. You can do L'Hopital's again. The derivative of the 4x is 4. The derivative of the bottom is e to the x. And now we're at a point where if we sub in infinity, we get 4 over e to the infinity. Any number over something that's growing without bound is 0. So number 8 is 0. All right, a couple more to wrap this page up. All right, e to the 2x over x squared. That's pretty close to the number 8, but when we sub in, we get e to the infinity over infinity, which means do L'Hopital's. Okay, so the derivative of the top is 2e to the 2x. Don't forget the chain rule. The derivative of the bottom is 2x. Subbing into this is again going to give me infinity over infinity. So do the L'Hopital's again. Take another derivative. The derivative of the top now is 4e to the 2x and the bottom is 2. So you can see in these last two examples, a polynomial expression like x squared here or up here, those are eventually going to get down to constants if you keep taking derivatives. And exponential, like e to the 2x or e to the x here, that's going to keep being exponential. So it's going to stay infinity as the other part eventually works its way down to being a constant. But what happens then is when I plug in, I get infinity on top, 2 on the bottom, and infinity divided by 2, still infinity. All right, and one more to go. As we approach 2, x minus 1 over x squared. If I sub in directly, on top I get 2 minus 1. So that's right away telling me I'm not in a situation where I'm going to get an indeterminate form. The bottom is 2 squared, which is 4. If you can plug straight in and get 1/4, then that's it. We're done. Game over. Don't assume every time you see a rational expression that it's going to be something you have to use L'Hopital's rule on. All right, so it's a good tool for getting indeterminates like infinity over infinity, 0 over 0. But don't forget, always just sub in straightforward, and if it works out, you get your answer easily and you can move on to the next one.